Hey guys, so today we are doing book 2, proposition 5. I'll read the enunciation real quick. If a straight line be cut into equal and unequal segments, the rectangle contained by the unequal segments of the whole together with the square on the straight line between the points of section is equal to the square on the half. So basically, we are given this line AB with the points C and D on it, and we are told that AC is going to be equal to BC. And we're trying to prove that the square of AD plus the square of DB plus the square of CD is equal to the whole square of CB. So we can start this one by saying that AC is equal to BC, which is given. And then next, we can create a rectangle out of the points CB and EF because of proposition 46. So we're going to extend this line CB and this line B, and we're going to create EF, and then we're going to create this line DG. And we're also going to create the line AK, which cuts across and goes to point M. And we have lines L and H in there. So after that, we're going to say that these lines are parallel to one another. So we can say that because of proposition 31, which is creating parallel lines, that CE is going to be parallel to DG and BF. And we can say that, like I said, because of proposition 31. So next we are going to say that the line AB and KM are parallel lines. So we have AB is parallel to KM, also because of proposition 31. Then we are going to create this line BE, which runs through point H. So BE. And we can do that because of postulate 1, which is to create a line with 2 points. So next we are going to say that the line AK and BM are once again parallel to each other because of proposition 31. AK is parallel to BM. So once we have that, we're going to start with the squares, and we are going to say that the square on CH is going to be equal to the square on HF. And we know this because of proposition 43. So the square on CH is going to be equal to the square on HF. Oh, sorry, this is proposition 31, and this one is proposition 43, which is creating things equal to one another that are on the diagonal sides of a line. So once we have that, we can add the square DM to that. So we add DM here plus DM here, which creates the square CM, which will be equal to the square of DF. And that will be because of common notion 2, which is adding equals to equals will create equals. So once we have that, we are going to say that the square on HL is going to be equal to the square on DF. So this square AL will be equal to the square on DF. DL equal to DF, and we can know that because of proposition 36. So once we have that, we are going to add the square of CH to both sides. And we can do that. We bring that here. So we add the square of CH to AL, and we add CH to DF. And that will be because of common notion 2, which is once again adding equals to equals, and then they will be equal. So now we can say that the square on AH is nom NOP. And that is because of book 2, definition 2. So, book 2, definition 2. And then once we know all of that, we can now say, therefore, the square on AD plus the square on DB plus the square on CD will now be equal to the whole of the square CB. Q